Here's problem 819. A 20 kilogram mass is fastened to a light spring constant 380 newtons per meter, that passes over a pulley as shown. The pulley is frictionless and the mass is released from rest when the string is unstretched. After the spring is unstretched, after the mass is dropped 0.4 meters, what is its speed? Alright, so we're going to release this mass at this point. Let's call that initial point point A. And as far as the spring is concerned, that's when the spring is unstretched, so we'll call that point A over here as well. Then we're going to let this mass fall, and at some later point it's going to reach point B. When that happens, the spring, which is connected to this string, will also be extended to point B over here. So we're going to have a distance here of x, which will be the same as this height difference here between A and B over here on this side. And that's that x and that h is going to be 0.4 meters, 40 centimeters. So x is also equal to 0.4 meters. Alright, let's compare A and B and apply our one equation to rule them all. We have that the kinetic energy at A plus the potential energy at A plus any work done along the way should equal the kinetic energy at B plus the potential energy at B. Now we're going to define our gravitational potential energy at B to be 0. That'll be our 0 height. So we are going to have gravitational potential energy at A, but A is no extended spring, so we're just only going to have gravitational potential energy at A, mg height at A. And we'll have only spring potential energy at B, 1/2 kx squared. Now we have kinetic energy at B, but we do not have kinetic energy at A. We start from rest, so no kinetic energy at A. And there's going to be no work done along the way because we don't have any external forces, no friction on the pulley, and no external force, so no work done along the way. We will have kinetic energy at B, so that's going to be 1/2 mass times velocity at B squared. So there's our equation that we wish to solve, and we want to find the velocity at B from this. So solving this equation, we have that 1/2 mass times velocity at B squared is equal to mg height at A minus 1/2 kx squared. Multiplying both sides by 2, dividing by the mass, and taking the square root, I have that the velocity of B is equal to 2 mg height at A minus kx squared, divided by the mass, square root. Just the algebra got me to that point. And so if I put in my numbers, I'm going to have 2 times the mass, which was 20 kilograms, times 9.8 for G. The height of A is 0.4 meters, minus K, which is 380, times X, which is 0.4 meters as well, squared, divided by the mass, which is 20, all this square root. If I figure this out, 2 times 20 times 9.8 times 0.4 is 156.8 minus 380 times 0.4 squared is 60.8. Oops. All this divided by 20 square root. So the square root of 4.8, I get 2.19 meters per second. So that is our velocity at point B. After this thing has fallen, we get a velocity of B of 2.19 meters per second. What we did is we started from the one equation to rule them all. We were able to evaluate 2 of the terms to be 0, and then filled in our other terms, solved for the unknown. That's our procedure on all these problems. Start from the one equation and then fill in our terms to solve for the unknown.